look at is how this equation right here that I'm circling has to do with all this information up here. So what we're going to do is we're going to break this down. It says a big ship drops its anchor. The L models the anchor's elevation in meters relative to the water surface t seconds after the ship drops its anchor. In short, what this is all saying is that after so much time has passed, the anchor drops so far. And what we're going to do is we're going to isolate this word problem. This little section here, which has got my rate times my time, this represents basically the distance dropped, okay, over a period of time. So basically, if it's 1 second, it's dropped by 2.4. If it's 2 seconds have passed, it's dropped by 4.8, and so forth, so on. This number represents where the initial height was. That number is the y-intercept. So if we were to draw this in a graph, your y-intercept would be here. So that's the concept. It's at 75 meters. And then as time progresses, it drops until it gets to the bottom type situation. So this is our initial height. Sorry for the bad handwriting. So the answer simply on this is 75. All right, let's look at this problem. Agent Hunt is transferring classified files from the CIA mainframe to his flash drive. The variable S models the size of the file on the drive in megabytes after t seconds of transfer. And here's our equation. How many megabytes does Agent Hunt transfer every 10 seconds? So, first off, this piece right here tells me where is my y-intercept. This is actually has to do with the size of the file, okay? And this happens to tell me how much transfer is done over time, okay? So knowing those two things, we can actually answer this question. How many megabytes does Agent Hunt transfer every 10 seconds? Well, let's put 10 in the place of t. You get 50. All right? That's how much he's transferring every 10 seconds. Rachel is a stunt driver, and she is escaping from a building that is about to explode. The variable d models Rachel's distance from her exit t seconds after the camera begins recording the stunt. What is Rachel's speed? Well, this is actually right here. That right there is your slope, but slope is also speed. So in speed, this is where I believe we're going to be getting, she is 38 meters per second. Now, why did I not put negative on this? Well, you cannot have a negative speed. This right here has to do something with physics. This negative that you see means that she is slowing down or going over a distance over time. And so what is showing a direction. This has something to do with high-end physics, and so, but just know this, it is a negative direction, but she's still traveling 38 meters per second. It's not an actual negative 38 meters per second because there's no such thing as negative speed, all right? But there is such a direction as a speed going in a positive direction and a speed going in a negative direction. All right, let's see. I'll try one more with you since that was 3. Let's do this one. Anumaya mows lawns. She charges an initial fee at a constant fee for each hour of work. All right, so we know that the variable F models her fee for working T hours. So we can actually say that this is that initial fee, basically just for her to even show up your door to start mowing, you have to pay her $6. And this right here is how much you will pay per Okay, that's the concept that's happening right here. And you can find, so what's her initial fee? Simply $6. All right, hopefully this will help you a little bit. It gives you a few problems to go through. Just kind of go back, watch these videos as necessary. If you need any more help, you know how to get up with me. All right, bye-bye.